All right. I'm going to do section 9 today. This is the last section. You might be asking yourself, wait, what happened to section 5, 6, 7, and 8? We're skipping them this year. You're welcome. Yeah. All right, we're moving on to section 9, which is trigonometric equations. You'll have an equation, which means you'll have an equal sign, right? And trigonometric means you'll have some trig function in that equation. So we're going to solve this. I'm going to say over the domain where x is from 0 degrees to 360 degrees. This is interval notation. This is the same thing as when x is between 0 and 360, including 0, but not including 360. That's what that soft parenthesis means. Don't include 360. Okay, so let's do this. How do you solve this? Well, you're going to treat it just like as if cosine of x had just been an x. You treat it the same way, right? But then we'll just have an additional step. So you want to subtract the rad 3 from both sides of the equation so that you get a 2 cosine of x is equal to negative rad 3. Then you want to solve for cosine of x. So you want to divide both sides by 2. So now you have cosine of x is equal to negative rad 3 over 2. Well, that's an angle you've memorized. You know angles that have a cosine of negative rad 3 over 2. So when I look at the unit circle, they want just to say that it's between 0 and 360 means they want you to just consider one revolution around the circle. Well, cosine is a positive rad 3 over 2 with a 30-degree reference angle, right? But negative, it would be here and also here. This angle and also that one. Both of them have a 30-degree reference angle, right? So if that's 30 degrees, then this would be 150, and this is 180. So adding 30, because the reference angle is 30 there, adding 30 would give you 210. So if cosine is equal to negative rad 3 over 2, then that means x is equal to 150 degrees and also 210 degrees. And that's your answer. Not bad, huh? All right, how about if the equation says secant of x plus 81 degrees is equal to 2, and we're going to go over the domain, same domain, where x is between 0 degrees and 360 degrees, like that. Okay, well, I don't know about you. I don't have my secant values memorized. I have my cosine values memorized. So that's what I'm going to do. I'm going to rewrite this. If secant's equal to 2, if secant of, this is your angle, right? If secant of an angle is 2, then cosine of that same angle is equal to the reciprocal, since secant and cosine are reciprocals. So I wrote it in terms of cosine because that's what I have memorized. All right. Well, this is your angle, right? I know cosine of an angle is equal to 1/2. I know those are memorized ones. So my angle is still going to be x plus 81 degrees right here. But I'm going to solve for when is cosine equal to 1/2 over this domain of 0 to 360. Well, cosine is positive 1/2 here, right? Because cosine is the x value. It's also positive here in quadrant 4. So what's the reference angle for cosine being 1/2? That's 60 degrees. And then you also want this angle here, which has a reference angle of 60, which makes this guy 300 and that one 60. So that means I've got two answers here, and that is 60 degrees and 300 degrees. Cosine of an angle is positive 1/2 when your angle is 60 degrees and when your angle is 300 degrees. Then you just want to solve for x, right? So you'll subtract 81 from both of these guys. So x would be 60 minus 81 is negative 21 degrees, and 300 minus 81 is 219 degrees. Yeah? Okay. Well, Here's the dealio, though. Negative 21, not in our domain. Not between 0 degrees and 360 degrees, right? But negative 21 degrees is right here, and I just need to go this way. So you'll go 360 minus 21 would give you 339 degrees. That's how you get that one. And now 219 and 339 are in my domain between 0 and 360. So your answer is 219 degrees and 339 degrees. You've got to make sure your final answers are in that domain. Okay, let's do another one. 4 times sine squared is equal to 3. And again, I'll do the same domain from 0 to 360. Hopefully I change up the domain. Oh, I do. Okay, perfect. All right, we want to solve for sine of x. So you would divide both sides by 4. So you get sine squared is equal to 3 over 4. And then you want to take the square root of both sides. Do you remember that when you take the square root of x squared, it's plus or minus? Same thing happens here. So when you take the square root of both sides here, it's plus or minus the square root of 3 over 4. Well, you can simplify that by saying it's plus or minus rad 3 over square root of 4 is 2. You've memorized when the sine of an angle is rad 3 over 2. That's a special angle. One of the ones you memorized, right? When sine is rad 3 over 2, that's the tall triangle. So it's positive rad 3 over 2 here at 60 degrees. And also here at 60 degrees, 120 degrees. It's a negative rad 3 over 2 here in quadrant 3, which is a 60 degree angle. 180 plus 60 would give you 240. It's also a negative rad 3 over 2 here in quadrant 4, 60 degree reference angle. 360 minus 60 will give you 300. So you have 4 answers this time. What? If sine of x is plus or minus rad 3 over 2, your x is 60 degrees, 120 degrees, 240 degrees, or 300 degrees. Those are all of the angles who satisfy this equation, and they all are in your domain. Okay, let's do another one. How about solving tangent of x times secant of x is equal to tangent of x if your x is in the domain of 0 degrees to 360 degrees. You're going to want to divide by tangent, but don't divide by tangent. You will lose solutions. You will also possibly be dividing by 0, and that's not okay. So don't ever divide by a trig function when you're trying to solve an equation, because it might be 0, it might be equal to 0, and then you've divided by 0 and done horrible. Instead, subtract and factor. Subtract and factor instead. And then you won't lose any solutions. So I've got tangent x times secant of x equals tangent of x. I'm not going to divide both sides by tangent of x because I might be dividing by 0. Instead, I'm going to subtract this tangent of x over to, I'm going to subtract tangent of x from both sides of the equation so that you've got tan x times secant x minus tangent of x is equal to 0. Okay, subtract and factor. They both have a tangent in common. So you have tangent of x, I'm going to factor it out of both of these terms. Tangent times secant will give me tangent times secant, and tangent times negative 1 will give me minus tangent. So I factored out the tangent, and then you set each factor equal to 0. tangent of x must equal 0, or secant of x minus 1 equals 0. I set each of these factors equal to 0. All right, so when is tangent equal to 0? Well, when y is 0, right? Since tangent is y over x, it'll happen here and here. So your x is 0 degrees and 180 degrees for this one. Solving for this one, secant of x is equal to +1. All right, I don't have my secants memorized. I do know that secant is the reciprocal of cosine. So cosine of x will equal 1 over 1. All right, well, that's just 1. And when does that happen? Cosine of x is +1 only right there when it's 0 degrees. By the way, this is a good point. All right, so it's here at 0 degrees. It's also at 360 degrees. But remember up here, the soft parenthesis says if you have an answer whose angle is 0 degrees and 360, you don't include the 360. You only include the 0 degrees. All right, so I've got answers of 0 degrees, 180 degrees, and 0 degrees. You don't need to repeat yourself. You just say your answer is 0 degrees or 180 degrees, since those two guys ended up matching, but you don't have to repeat yourself. Okay, let's do another one. How about cosine of x plus 2 equals 3 times cosine of x if x is in the domain of (0 to 2 pi. All right, I'm not a fan of this question, but whatever. All right, this means if you get a 0 or a 2 pi, you don't include the 0, you do include the 2 pi as your answer. All right, why don't you try this one on your own, because it's a simple solving. This is a very simple solving. So I'll pause for a minute while you pause the video and see if you get the right answer. All right, hopefully you paused. Hopefully you tried it on your own. What you want to do is combine like terms, subtract the cosine of x from both sides, and you'll have a 2 is equal to 3 cosine x minus 1 cosine x is 2 cosine of x. Dividing both sides by 2 will give you that 1 is equal to cosine of x. And when is that true? Well, same as last time, right? Right there is when cosine is 1, so x would be 0. That's normally how you would answer it. However, 0 is not in the domain, since this time our domain gave a soft parenthesis on 0, but a hard bracket on 2 pi. So your answer should have been x is 2 pi on this one. It's very rare that you're going to see that. Most of the time, if it's 0 to 2 pi, it'll be a hard bracket on the 0 and a soft parenthesis on the 2 pi. That's what's normal. That's the only kind you'll see next year and the year after and all of that. It's very rare. This book likes to do these crazy domains. So anyway. All right. How about 2 cosine squared plus 3 sine of x minus 3 equals 0. And we're going to do over the domain of hard bracket on the 0. This is what's normal. Soft parenthesis on the 2 pi. So that means if you get an answer of an angle here, you're going to give 0 as your answer and not 2 pi. That's what's typical in most math books. All right. Well, you got a cosine squared and a sine. What you want to do is write them as the same trig function. Because you can't factor it the way it is. Like, I know the tan example 5 had the same trig function. Both of them were in terms of cosine. examples 1 through 3 were all a single trig function. The only one that wasn't was this guy, tangent and secant equals tangent, but they had something in common, so I was able to subtract it and factor. Can't do that with this one, right? We have a cosine squared and a sine and a 3. There's nothing in common right now. So that's what your goal is can you write them as the same trig function? And you can because of the Pythagorean identities. I know that sine squared plus cosine squared is 1. Yeah. So that means I can write, I've already got a sine here. So what I really want to do is write cosine squared in terms of sine. So if I subtract sine squared from both sides of the equation, and if this is an identity, then another identity is that cosine squared is equal to 1 minus sine squared. So that's what I'm going to replace this with. So it's a 2 times, and instead of cosine squared, I'm going to replace it with 1 minus sine squared. And then I have a plus 3 times sine of x, and then a minus 3 equals 0. We'll clean this up, at least, okay, so now I've got everything in terms of sine. Lovely. Let's distribute this 2. You'll have a 2 minus 2 sine squared plus 3 sine of x and minus 3 equals 0. Okay. Got a 2 and a minus 3, so that makes it a negative 2 sine squared plus 3 sine of x. 2 minus 3 would give you a minus 1. Okay. What I really want, here's what's going to happen, right? This guy factors like a quadratic. It's not truly a quadratic, but it takes on the quadratic form. Yeah. If I have an x squared, blah, 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 right? It's easily factored. I really want this to be a positive squared term though, so because it's easier to factor that way. So you can imagine I'm going to add it over here. I'm going to subtract this one. I'm going to add that one, right? So that I get, or you can think of it as I'm going to multiply both sides by a negative 1. But I really want my squared term to be a positive value. So it's a positive 2, a minus 3, and a plus 1. Okay. And why would I do that? Because this factors the exact same way as 2x squared minus 3x plus 1. If I know how this factors, this will factor the same way. The only difference is instead of it being x times x, it's going to be sine of x instead. So this guy factors as a, well, I'll show you the long way. Do a refresher. Remember that when there was a number in front here, you're looking for two numbers that multiply to 2 times 1 and add to negative 3. So two numbers that multiply to 2 and add to negative 3 would be a negative 2 and a negative 1. Because negative 2 times negative 1 will give you a positive 2. And negative 2 plus negative 1 will give you a negative 3. And so what we would do is rewrite this middle term using these two guys. So 2x squared minus 2x minus 1x plus 1 equals 0. Notice all I did was rewrite the negative 3x as a minus 2 and a minus 1. And then you do factoring by grouping. Look at the first two. What do they have in common? This is a 1, not an absolute value. What do they have in common? They have a 2x in common, and you would be left with an x minus 1. Look at the second two, and they don't have anything in common. But remember, you want your parentheses to match. So if I factor out a negative 1, I'd be left with x minus 1. And so parentheses match, that's one of your factors, and the other one comes from here. That is a review. Hopefully you totally remember how to factor. And do you have to do it this way? No, I learned it guess and check. So if you can figure out how it factors by guessing and checking, you can do it that way too. All right, so what does this mean? The only difference between here and here is that instead of it being a x squared, it's a sine of x squared. And instead of it being an x, it's a sine of x. So you just replace the x's here with signs. So this factors as sine of x minus 1 times 2 sine of x minus 1. You can double check yourself, FOIL this out, right? First times first is 2 sine squared. Outer and outer is a minus 1. Inner and inner is a minus 2 sine. So minus 1 sine and minus 2 sine gives you minus 3 sine. Last times last gives you a plus 1. Yay, we factored it correctly. Okay. Now you set each factor equal to 0. Sine of x minus 1 equals 0, and 2 sine of x minus 1 equals 0. So sine of x is equal to 1 here. Well, sine of x is 1 at 90 degrees, right? Except that we're in radians. So what is that? X is pi over 2. This one, add the 1, divide by 2. Sine of x is positive 1/2. Where does that happen? That's short triangles, right? But sine is positive here and here. So 30 degrees and 150 degrees, but in radians, pi over 6 and 5 pi over 6. And so your answer is pi over 2. I guess I could, if you do it in order, it'd be pi over 6, pi over 2, and then 5 pi over 6. In order, like as you go around the circle counterclockwise. Whatever. It's usually how we do it. I don't ever mark kids wrong for not putting them in that order. I would have been fine with pi over 2 and then pi over 6 and then 5 over 6, but good. All right. One more. Tangent squared plus tangent equals 0. And we're going to go over the domain from 0 to 2 pi, including 0, but not including 2 pi. And that means radians also. You know what? Try it on your own, because this one's a fairly straightforward one also. Pause the video at this point, try it on your own, and then come back to me. Did you pause? All right, hopefully you paused and you have come back and you should have gotten 4 answers. Did you get 4? I hope so. It's a fairly straightforward one. They both have something in common. They both have a tangent in common. So let's factor it out. Set each factor equal to 0. So when is tangent equal to 0? Well, it's y over x, so it's when y is 0. So here and here. So x would be, you're including 0, not 2 pi, so it's 0, and then this one would be pi. Here it's tangent of x equals negative 1. When does that happen? Well, tangent is positive 1 with a 45-degree reference angle, but negative 1 in quadrant 2 and in quadrant 4, right? Because your y over x is negative and positive. All right, so that gives you this quadrant 2 angle is 3 pi over 4, and quadrant 4 is 7 pi over 4. And I'm just going to square those because there's your answer. 4 answers. I hope you got them all. That's a 7. Should have separated that a little bit. All right. In your textbook does some very funky domains. Really bad. Yes? My directions to you are, if you see degrees in the domain, then do it from 0 to 360. And if you see radians in the domain they're asking you to do, then go 0 to 2 pi. And here, so the answers in the book will be slightly different than the ones that I want you to give. Here's the answers to your homework. It's 1 through 17 odd. But I want you to do this domain so that way you can just double check what it is. The book does some funky domains on that thing, so and you don't need to do that. Okay. I hope you all have a fantabulous day. This was the last lesson. It's the last time you're going to see me on a recording. Bye.